Welcome students on today's lecture on equilibrium of forces. In the previous lecture we have discussed about the force system as well as Lami's theorem. So let us start with the numerical problem. So let us discuss about the numerical problems on spheres. I am Professor Sagar P from Civil Engineering Department, AITM, Belgaum. Let us take an example. So example number 1. A cylinder of weight 600 Newton rests on smooth surfaces as shown in the figure. Determine the reaction at contact points. So this is a sphere which is rested over the two surfaces, that is this and this, and it is these surfaces are making an inclination of 60 degrees and 30 degrees respectively with respect to the horizontal. Now this sphere is resting on these surfaces, and in the question it's clearly specified that to determine the reactions at the contact points. So the sphere is in contact with this surface at the point A and on this surface at point B. So there are 2 points of contacts. So before starting any of the numerical, just check how many number of forces are acting. That is, forces may be a self-weight and the reactions. So we have for the cylinder a self-weight, that is 600 Newton. This will act towards the CG of the earth. So self-weight of 600 Newton. And the reaction is developed at the contact surfaces. One is at A, one is at B. Now let us draw a free body diagram for this numerical. So this is the given numerical. So let us bring out this sphere. So the self weight is acting downwards, which is having a load of 600 Newton. And at the contact surface at A, a reaction is developed RA, and RB, a reaction developed at B. So these all together keeps the body in equilibrium. Now let us draw the force diagram for the sphere. So what we can do is we can place this RB at this point and we can place this RA at this point. Using this relation, we have to find out what are the angles made by the two reactive forces RA and RB. Now let us draw the force on the sphere. So forces acting on the sphere. So as we can see, the self weight is acting downwards, which is taken as W equal to 600 Newton, and the reaction which was at the left has been placed here, which makes an angle of 60 degrees, and the reaction RB, which makes a contact surface with B, which was at the right, has been placed here, so which makes an angle of 30 degrees. Now if we see in the force diagram, we have three forces acting at a point, that is at the CG of the sphere. So as here we have three forces, we can apply Lami's theorem. Remember, the Lami's theorem can be applied only on the force system wherein there are three forces and which are acting at a single point. So in short, it can be said that it can be applicable for coplanar concurrent forces. So let us apply the Lami's theorem. So applying Lami's theorem, states that the force considered is directly proportional to the angle made by the other two forces. So let us take the force RA first. So RA divided by sine of angle made by RB and W. So this angle. So this angle is, this is 90 degrees here plus 30, totally 150 degrees. So it is RA. So 90 plus 30, 120 degrees. So RA divided by 120 degrees. Let us consider the next force RB. So RB divided by the sine angle made by RA and W. So here we can see this is 90 degrees and this angle is 60. So 90 plus 60, it makes 150 degrees. Hence RB divided by angle made by this sine of 150 degrees, which is equal to the third force W. So W, which is 600 Newton, divided by the angle made by RA and RB. Now this horizontal line makes an angle of 180 degrees. If we deduct 60 and 30, we get the angle made by RA and RB. So this is 90 degrees here. So hence 600 divided by sin 90. Now we need to find out the reactions at the contact points, that is Ra and Rb. Let us solve this considering two equations. So let us take this component and this component first. So solving, we can see this has been brought here, this has been equated here. So Ra, after solving, we get 519.615 Newton. Now next contact point is Rb. So let us take this equation. So Rb divided by 750 degrees equal to 600 divided by 790 degrees. Hence, after solving, we get Rb is equal to 300 Newton. Hence, we got the reactions at the contact points Ra and Rb. This is how we need to find out the forces. Now let us study one more numerical. So example number 2. The statement says that a roller of weight 10 kilonewton rests on a smooth horizontal floor and is tied by a rope AC as shown in the figure. Estimate the force AC and reaction from the floor if the roller is subjected to forces as shown in the figure. Now this is a roller which is having a self weight of 10 kilonewton and is rested over a smooth horizontal floor which is tied to a rope AC. So this AC is a rope. Then what we need to find out is the force in AC. So force in this and the reaction from the floor, that is at contact point between the roller and the horizontal surface. Now these are the forces acting on the roller. Now this roller is having a self weight of 10 kilonewton which will act downwards, and the rope is attached on A to C. So obviously the rope will have a tensile force. So this is how it acts, and which is acting at a 30 degrees. A horizontal force 10 kilonewton is acting and an inclined force of 7 kilonewton is acting on the roller. Now let us see how the free body diagram is drawn. So this is the free body diagram. Let us take the self weight first. So this roller has a self weight of 10 kilonewton which will act downwards. So has been taken here. The next, the tensile force made by rope AC, that is force in AC, has to be found out. So this has to be placed here. Now the angle made by it will be 30 degrees. However, we have this angle 30 degrees. So obviously the opposite angle here will be 30 as well. Next, the 10 kilonewton force horizontal will be acting as it is, and the 7 kilonewton inclined force making an angle of 45 degrees will act as it is. Now we have a contact point at the horizontal floor and the roller. So this is creating a reaction Rb. So this is how the free body diagram of roller at C has been drawn. Now let us draw the force system for this free body diagram. Now the weight has been placed here, tensile force is as it is placed here, then horizontal force and 7 kilonewton inclined force. So in total we have here 1, 2, 3, 4, 5 forces, out of which 2 are vertical, 1 is horizontal and 2 are inclined. So we need to resolve these inclined forces. Now let us start resolving. Now here we have 5 number of forces, hence we cannot apply the Lami's theorem. Hence we should apply resolution and composition. So starting with applying the equations of equilibrium. So let us say we will resolve these forces along f of x and f of y. Let us start with resolving the forces along x direction. So f of x equal to 0, taking forward at positive. Now solving. Now this is a horizontal force, so 10 positive plus this is going downwards, so the obviously horizontal component will go like this. So it will be minus 7 cos of 45. Then this also minus t cos of 30 degrees. These are vertical, hence not be counted. Now in this t is unknown, so we can find out t. So t is working out to be 5.83 kilonewton. Now let us apply summation of f of y equal to 0 upwards positive. Now let us consider the forces. So we can take minus 10 downwards, minus 7 sine 45 downwards, minus t sine 30 downwards, and rp upwards positive. So let us find. However, we have the value of t. We will substitute this value of t here so that we can get the reaction at B. After substituting, we get the reaction at B as 17.87 kilonewton. So in the question they had mentioned that find out the the tensile force in the rope AC. So this is the tensile force in the rope AC, which is 5.83 kilonewton, and the reaction at the contact surface between the cylinder, that is roller, and the horizontal surface RB is equal to 17.87 kilonewton. So this is how we need to find out the forces acting on the sphere, making into use of self weight and the other forces, and find out the reaction at contact surfaces. So thank you. So all students, be safe, stay home. Thank you.